I've been doing a little more electrical work on the Dodge van. I've spared you guys footage of that because I don't want to bore people to tears on electrical work. But just to catch you up a little bit and show you what I'm doing right now. You saw that I got done in the engine bay and I started working on the dash instrument panel and the area up there. Excuse me. So I went through the dash, pulled all the bulbs out of it, cleaned up the bases, cleaned up the sockets, tested the bulbs. Half of them were bad, so I replaced those. And I went on to figure out why I didn't have taillights and headlights. And it turned out to be a couple of things. The first step was replacing the headlight switch, or the light switch. I had a used one in stock that works mostly, and this one here just seems to be dead. So replacing that got me taillights, but I still had no headlights, although I was getting power out of this. So this was working like it should at that point. So I went to check the high-low beam switch on the floor, the dimmer. When I went to pull the plug off of it to check for power, it fell apart. So there's my problem. so figured I'd show you what this consists of and what I'm going to attempt to do to repair it. But what it is, this is a really common dimmer switch. It was used in the American cars from the 50s, 60s, and 70s. I mean, GM, Ford, Dodge, it didn't matter. A lot of them used this floor switch with the 3 wires on it. And all it is this bottom leg here is your input power, and then it's bridged to these 2 terminals, and then up here there's one side is low beam and the other side is high beam. So that means down here you got power to both of these at the same time, and whichever one of these you're putting power to determines if you're running high beams or low beams. So there's contacts in here, and the foot switch has just got a rod through it, and there's a cam down here, so when you click it, it just switches it to the other side. You can tell this one's kind of sticky. So I'm going to try to clean up all these contacts and maybe put a little lube back there and then put this back together, because all it is this goes in here, and then these ends are peened over. That's why there's this ridge on both sides. They just peen the aluminum into that ridge and it locks it in place. And this side is still peened very well, but this one hardly at all. So it just let go, and that's going to be the problem. Now, whether or not I can get these contacts clean and working good enough, we'll find out. These switches are very inexpensive, but they're not stocked by most places anymore. You have to order it or get it online. But we'll give it a shot. And I do know this is my problem because I can plug this into the harness and just jump the terminals, and I get my high beams and low beams. So this is definitely the issue at this point. Now, 2 other problems I have, well, one, but they're kind of related. These are what Chrysler used in the 60s, probably even in the 70s too. But the switch itself is pretty basic, but they have this variable rheostat on it, and that is what operates the dimming function of the dash lights. So there's a contact there, and you can see there's an open wire there's an open wire winding in there, so it's a variable resistor, and as the contact just goes across that, it adds or reduces. We got a break in the wire right there. That's probably why that one doesn't work. In fact, that one's even missing the contact. So anyway, it adds or reduces the resistance and feeds current to the dash lights. And these almost always fail in the early Chryslers. Like I had mentioned before, that's one area where Chrysler cut corners, was in their electrical systems. They are really basic, which on one hand makes them easy to work on, but the other hand, they're also not incredibly reliable. Although when you consider how old they are now, they have a reason to fail. But even 30 years ago, when they weren't so old, they still failed. You could get everything else in the car working and you'd never have dash lights. Sometimes you could fool around with it and find a sweet spot, one little area where the lights would come on, and that's what you had. But this one is dead. Like we just found out, the wire resistor is actually broken and it's missing the contact. You can see on this one the contact comes off of that leg, and that's what rubs up on the resistor there. Now if you really had to, I'm sure you could pull these tabs back, open this up, clean the contacts inside it, put it back together and put it back in service. I'm sure that's completely doable. But another thing is too, it's a matter of how much your time is worth, because again, these are not in stock, but they're still inexpensive. I looked online, your parts store or Rock Auto can get these for under $10, so you just have to weigh how much your time is worth. But my used one works fine with the exception of that. Now, here's another difference between the truck and the car. On the car, when you turn your lights on, the power from the taillights will come off of whatever terminal is your taillights, go to the fuse box, and then to the taillights. But in the truck, the power goes from the fuse box to the switch and to the taillights. The reason I mention that is with the car, a workaround for this bad resistor, bad rheostat, is there's also a fuse for your dash lights, and that's actually the dash lights there. So, and it is post this switch. So power goes to this, to the fuse box, and then to your dash lights. So if this is working properly, you put your tester on that fuse and you can change the resistance, and your test light will brighten and dim at the fuse box. So what I'm getting at is that when this goes bad, all you really need to do is run a jumper wire from your taillight fuse to your dash light fuse. So whenever you turn on your lights, it's powering your dash lights. They'll be on full brightness, but that's not a big deal. But that's how to get around having this bad rheostat. But I can't do that with this one because the fuse is pre-switch, and it's the same fuse that runs the brake lights, so it's hot all the time, and this is just what engages it. So that's a big change from the automobile. So the only way I could really get this work, this is the tail light lug here, this is the dash light lug here. I have to make a connection between these two, including the regular plug. So either I'm going to have to put a small wire through here to jump it, or go through the top and jump it. Obviously I don't want to alter the factory wiring. I don't want to be a butcher like the previous owners. I'll leave the factory stuff alone, so I just have to figure out how to get around that, so that way when the lights are turned on, the dash lights come on automatically. So with this thing, we're just going to take our little wire brush here and clean the contacts off of it. Gingerly clean this one. We don't want this thing spilling its guts. And we got to figure out how it goes back together. Like that. Well, I guess that gives us a chance to look at it. So there's the cam. And okay, so that pin there comes straight down on here, and whichever way it is, it just rocks it the other way. So the next time it comes down, it rocks it that way. Pretty simple. So I'll just add a drop of oil to that stud. And drop of oil there. I think I'll get some oil up in the body as well. There we go. Okay. Clean that side too, pretty corroded. These switches really take a beating because obviously they're being down there on the floor. They're exposed to moisture, direct water, grit, grime, dirt. People angrily stomping their foot on it. Obviously some people are heavier and stronger than others, so they end up crushing it harder than it should be. It managed to survive a lot of years of that, but it's definitely rough on them. Okay, on this one, this power blade was down here towards the bottom. I have seen a few that were like this. It's really not going to make a difference either way because the contacts, the power input and output, it's going to be all the same. But I will copy the way this one came out because the harness obviously has developed a memory from where it was, from the position it was in the vehicle. Use a couple of twist ties to hold it together while I peen it over. Okay, so mechanically it's working. And we just have to find something to check continuity with. Okay, right here is where I pinned it back in to hold this in place. And what we're going to do is check that we have continuity between the main lug and one of the outputs. And then when we click it, that continuity should change. That continuity should change to the other outlet. On the headlight switch, I soldered a small jumper between the tail light and the dash lights. So that means the dash lights will illuminate whenever the lights are on. I don't think that's going to interfere with enough of the spade when I clamp it back together. If it does, I'll just remove it, but it's not going to hurt to try. And it'll still have fuse protection because the tail light lug is protected downstream, so the power comes into this lug from the fuse box. I should say the power comes into the switch, then into the lug, and then that'll protect both of these from the downstream power source. I have the fluke set to diode tester because all we are looking for is continuity. Nothing there. Something there. So now we switch it over. We have continuity there. And we don't have it there. So this switch is functional and ready to reinstall. And this switch is ready to reinstall. So all I have to do is put these back in and put the instrument cluster back together, and I should be done with the electrical, and we'll be able to move on to the carburetor. Okay, here's an update on what I'm doing now. My little jumper wire in the light control wasn't such a hot idea. It did lift the terminal plug high enough to where it wasn't getting a great connection. The lights would work, but if I wiggled it a little bit, they'd stop. So I took that off so we can get full engagement again. And what I ended up doing here, it's a little more intrusive than I wanted to do, but it'll have to suffice. This wire here is the power to the tail lights from the light switch. So I tapped into that, and down here is the power to the dash lights where it plugs into the fuse box. And since that function on the light switch does not work anymore, I'm just going to unplug that from the fuse box and then plug my jumper or my tap, plug my tap into that. Okay. So now I got my tap plugged into that, so when the lights turn on, it'll feed the tail lights and it'll feed the dash lights. I'll put a little black tape around that for a little extra protection, but that's the game plan. Okay, just about have the electrical wrapped up here. I got both the dimmer switch and the headlight switch wired in and hooked back up, and we have functionality. So those two bulbs are our dash lights. Headlights are working. You can verify that via the ampere gauge. So that's low beam, high beam, even have a high beam light. So this electrical's coming back rather nicely. And we'll do a light test when it gets dusk. Right now it's too bright out here, but it's looking good. So I still have the seat forward, passenger side seat, from working on the electrical here. And look at what I noticed. Think that's how that windshield got took out? I would hope that there was some way of restraining that back when the van was new. Otherwise, that's just a terrible design. At least it's flat glass. It'll be relatively inexpensive to replace. Right now I'm checking on this one rear light to see why it's not working. Look what they did here. They actually have bolts or screws coming around from the back side out and put nuts on it. Not quite sure how they got to the back side of it. Okay, all back together. I recognize this little square because I've also got a hint next to me. I'll tell you about that. It was back in the early 90s. California had this, another one of their emission scams going on, where they were trying to reduce NOx emissions, and they had, I think it was just called a NOx kit, something like that, but the smog techs were required to install it in vehicles pre a certain year. And all it was is they removed the vacuum advanced, capped off both ends, and then retarded the timing to the point where the engine hardly ran. And then they would put a little sticker here that, authorized by the state of California. This vehicle is equipped with the NOx reducer kit, or whatever the heck it said. It was a little yellow sticker that size. They were obligated to put that on your dash. And then in the engine bay, it got this sticker with the specifications on it. Fortunately, it was a short-lived idea because it just really hurt performance. Oh yeah, this sticker also said this vehicle is not to maintain speeds above, I forget, it was a odd number, like 54 miles per hour or 50, whatever. But they had your speed really reduced, and it was on that sticker. And so, of course, back then, you'd go in, get your car smogged, they'd put that crap on it, and you'd get it home, put the vacuum advance back on it, and get it back to factory. But that was an instance where the smog was trying to make you go beyond factory and hurt your emissions and your mileage by their stupid little kit. So you'll still see some of that stuff floating around on old vehicles, or if you look at ones in wrecking yards, once in a while here in California, you'll see that little yellow sticker right there. So I cleaned the glass off, I cleaned the bezel. Looks a lot better than it did. And I did drop that fuse box, pulled all the fuses, cleaned all the connectors, put it all back together, and replaced that burned up wire on the ignition switch. Okay, I opened up this side to see why this taillight doesn't work. Hopefully it's just the bulb. One of the legs is burnt out. I looked at the number though. It's a 1034. I've never seen one of those before. It's got all the same characteristics as an 1157. And older vehicles almost always use the 1157s. So, being the curious person I am, I looked it up online. And this actually is extremely close to an 1157. It has two legs. The low one is for the taillight, and the brighter one is for the turn signal and the stoplight. Same as an 1157. The low element is identical to the 1157. The bright element is a tad lighter, dimmer than an 1157. So there's not really much point in even running one of those. But it's a new one to me anyway, so let us see if this is going to fix the problem. I'm going to spray a little electrical cleaner in there. Well, it's lighting up. I think I need both hands to turn it. Okay, the bulb's part of the problem, but I have a terrible ground back here. I had the lens back in place, but then the screws weren't tight enough to get a bite into the rust to give me a ground. And if I tried to torque them down too much, I'd crack the lens even more than it is. So I'm going to get some sandpaper and clean these contacts up and put it back together. A little cleanup and we're back in business. Okay, I don't know how well this camera works in the rain or the dark, but we're going to find out. I have the electrical finished up on this thing, as far as I'm going to go with it anyway. So, here is our parking lights. Hold on a second. Okay. I just moved it over to auto, so hopefully it'll do a better night vision. So there's the dash lights with the parking lights on. And I'm tripping over boulders. So there's our tail lights. One of the markers is out. And I know there's a headlight that's out too. There's the low beams. There's the high beams. So the next time we're on this, we'll be on the carburetor. So thanks for watching.